to my tutorial, the tutoring tower. Before we start, let us just pray. Father, we thank you for today. We thank you for the time. May you guide us and protect us, everybody watching. May you give a spirit of understanding. Yes, we grant it everything unto your able hands. In Jesus' name, amen. Alright, so today we are considering a certain topic that I need you to take note of. A general topic is general arithmetic. General arithmetic. This is the topic that we are going to consider for today, and I need you to understand several things that you need to take note of. I'll be very short, but you have to take note of what I'll try to explain, and from there you will be able to understand general arithmetic. Welcome everybody who is watching wherever you are. I'm so excited that you are with me watching the video. Alright, so I need you to take note of these two things that we shall be focusing on. So at first we shall speak about standard form, and secondly we shall speak about what we call ordinary form. So these are the two things that determine what we call the general arithmetic. I think I'm clear there. So these we shall speak as a whole, but before we speak of anything, I want you to consider this formula that I'll explain here, which says a times 10 to the power of n, with the a times 10 to the power of n. This is a formula for what we call standard form. So anything that has to do with standard form, this is the formula. So I'll try to explain very faster that what does this mean. A will be speaking about, it represents a number which is between 1, a number between 1 and 10. With the any number between 1 and 10, it might be 2, it might be 3, up to 10. With the up to 9 there, going there. So that is what we'll be speaking about. A number which is between 1 and 10, so it's signified by this a. What about that n? That is n, the power there. N represent a whole number. N represent a whole number. So whenever you capture this is the formula that will guide you throughout doing whatever you shall do. So a lot of people, we shall go straight to the questions so that you can understand what I'm trying to illustrate here. Are we there? Alright, thank you so much. Alright, so maybe for example, let us quickly rush straight to the questions of today so that everybody can understand what we are trying to say. Alright, maybe you're given something like 0, 0, 0, 0, 0, let's just say 5. Then this number is initially it is in ordinary form. It is in ordinary form, right? They give you maybe on mathematics paper 1, they say change this number to standard form. Are we there? So the easier method for you not to be confused, because a lot of people, they are confused when it comes to this format, whether their power should be having a negative or should be having a positive, and they are confused to write a proper number here. So I'll show you a key concept not to be confused. So what you do here, you first change this number to a proper fraction. Since this one is a decimal fraction, you change it to a proper fraction. Okay, so changing to a proper fraction of this number, you have to just understand the numbers after the comma. You take this number, are we there? You take the last number, which is 5. Then you check how many numbers are after the comma. 1, 2, 3, 4, 5. So we've got 5 numbers after the comma, meaning it will be over 100,000. Are we there? Yes, 100,000. So it is 5 over 100,000. I think it is clearer for everybody. So if it is 5 over 100,000, then the next thing that you're gonna focus on, you try to analyze that this 100,000, it is the same as, or it is whatsoever, what can I don't know, is similar to 5 over 10 to the power of 5. So whenever you understand this concept that it is 10 to the power of 5, why? Because we've got 5 zeros that we have here. 1, 2, 3, 4, 5 zeros. So we have got 5 zeros, so it's already automatically over 10 to the power of 5. So now you are already on the safe side. Are we there? You are already on the safe side. It will already usher you to your answer, and there is nothing that shall be difficult for you from this concept already. Are we there? Alright, so let me show you that there is nothing that shall be difficult. So this thing, for you to understand, remember, I'll touch something on indices, but anyway, indices, they explain that if we have got something like let me just say I've got a number which is x to the power minus a, x to the power minus a. Maybe this is, I didn't take a number, but I represented it in a letter, x to the power minus a to the exponent minus a. It is the same as, you change it to 1 over x to the power of a. Are we there? That is the law of indices that we have, because we are not allowed to leave this power as a negative. But when it comes to standard form, you are allowed to leave it as a negative on the power, because standard form, whether is it a negative, whether is it a positive, it is up to them. They know what they are doing. But anyway, above all, you have to understand that initially on indices we have to leave it like this, but now I need you to understand this concept that if we have got something like x to the 1 over x to the power of a, it is the same as x to the power minus a. So we are going back to the same thing. Are we there? So now, for you to understand what I'm trying to say, here we've got 10 to the power of 5. Are we there? We've got 10 to the power of 5 downwards, down this line, down this line. So meaning this 10 to the power of 5, if it comes on top here, I'm already having something like 5 divided by 1 over 10 to the power of 5. You understand what I'm trying to say? Divided by 1 over 10 to the power of 5. I guess you understand what I'm trying to illustrate here, because this is divided by 1 over 10 to the power of 5. So now for me, since on division we have to say 5, when we are division, we change this to a multiplication sign, and we say 10 over 10 to the power 5 over 1. Now I need you to understand on this concept, but remember, come back to this thing that we are speaking about here. I just did for you to understand that where are we taking this mathematics to. Come back to this concept that here initially we had something like 10 to the power 5, and here we had initially x to the power minus a, meaning when this 10 to the power 5 comes on top, now it will be having a negative power. It will be having a negative power. So when you are done, you can just say 5 times 10 to the power negative of 5. This will be automatically your answer. You are done. You are safe and sound. That is the correct answer for this problem that you are having. So when you understand this from this concept, you now know, because there are other people, they don't know whether is it a negative, should I move on the negative or should I move on the positive. So this is the understanding that you have to understand whenever we come to ordinary to standard. Are we there? So anything you'll be done whenever you consider this. So let us move to the next segment that we have. Suppose we've got a certain number like 0,00033, right? Somebody can ask, I've got this certain number like this. We still apply the same concept, a times 10 to the power n. Are we there? Just don't forget this format, because this format shall guide you and help you wherever you are going. Are we there? All right. Hope everybody's understanding and is on track. Okay, here what you do, you have to understand that how many numbers do I have again after the comma. Whenever you understand how many numbers do I have after the comma, it will help you to go away with this mathematics. But remember, the number has to lie between between 1 and 10. So here we've got 1, 2, 3, 4, 5 numbers. But it is not okay for me to write 5 numbers, because if I write 5 numbers, I'll be now having 33 over those 5 numbers, which is not proper for me. But whenever we come to ordinary form, I have to move my comma until I achieve something like a number which is just in between 1 and 10. So I'll move my comma 1, 2, 3, 4. So I've moved my comma 4 times. Are we there? I've moved my comma 4 times. I'll attend 3, 3 over how many? 1, 2, 3, 4. Sorry, 1, 2, 3, 4. Are we there? So instead of 100,000 this time, I'm having now 10,000. 3, 3 over 10,000. Then automatically, I now know my 3, 3 is between 1 and 10. I automatically know that it will be a 3, 3 over 10 to the power of 1, 2, 3, 4. Over 10 to the power of 4. Now there is no longer use for us to go back to the same thing that we have been doing here of saying invert and multiply. There is no longer the same concept. You now know, because I have now illustrated, I shaded a light so that you can understand this way. So now it is the same as, you now know I've got my 3, 3 times 10 to the power negative 4, because this will change on top to be negative 4. Are we there? So guys, this is what we have. So this is exactly what we have. We are done on this part, and there is nothing more and there is nothing less to this part. This is the concept of standard form to ordinary form. That is the concept. Then next we want to consider the part that deals with let's just say they give you something which is in standard form, then you have to change it to ordinary form. I'm having a number, maybe something like 4 times 10 to the power negative 4, right? They say change this number to ordinary form, Are we there? To ordinary form. So I'll be knowing that for me to change this number to ordinary form, I need to understand that what is my exponent here? My exponent is negative 4. My exponent will guide me back to what to do on the ordinary part. So this exponent will tell me about the numbers after the comma. Whenever you catch and capture this exponent, it is telling you about the numbers after the comma. So you can just go on to say 4 over how many numbers after the comma according to the exponent. Don't worry about the sign of the exponent. Just worry about how many numbers. We've got 4 here, numbers after the comma. So it is over 1, 2, 3, 4. So it is over what? 10,000. Then the next thing, you can just literally divide, or it is the same thing. Somebody can be confused to say 1004. Yes, I know people have got confusion a lot, but just write your 0 comma, and you know that the next thing from here, my numbers have to be 4 after the comma, so the rest have to be zeros, and the last number has to be 4, but I have to maintain that they must be 4 according to this exponent. So I'll say 1, 2, 3, and I'll write my 4. So this is the correct definition of these two ordinary form. And let's go again. Maybe somebody have got something like 5,2 times 10 to the power negative 7. Right, somebody has got something like this. Right, I'm just creating my examples on my own so that you can understand what I'm trying to say. 5,2 times 10 to the power of negative 7. All right, so for you to understand this, you have to understand the exponent again. The exponent is very crucial. It is the one that will guide you on anything. The exponent is negative 7. So you are dealing with 7 numbers after the comma. So 5,3 over how many numbers? That is 1, 2, 3, 4, 5, 6, 7. So it is over 10 million. That is the exponent. Are we there? It is over 10 million. Okay, that is our exponent there. All right, so further on, I'll move on to see what is being represented by this mathematics, because I've attained over 10 million. So now I'll count. Let my numbers be, for this case, your numbers will never be 7, as initially I've said there. Are we there? Your number will never be 7, because we now have got a case. Sorry, I've said 5,3 there is 5,2. Sorry for that. Initially, your number will not be having 7 here, numbers after the comma, but instead here what made us to have 4 numbers after the comma, it is because already have got a single number, but here we've got a double number, 5,2. 5,2, if you dissolve a comma, same as 52. Are we there? So we can't attain the same thing as here, but now it's different. Here you just have to take note of that I have got what? 7 numbers after the comma. I mean, this exponent is to the power of 7. So therefore, instead of me having 7 numbers after the comma, they now have 8, because I've got 5,2. So 1, 2, are we there? 1, 2, are we there? So that is what you have to take note of. So initially, if we had 5 over 10 million, we could just say 5 over 7 numbers, because 1 plus this million, I mean, if we had 5 over 1 million, we could just say 1 plus these zeros. But now we have to understand that the first part is on 10 million into 5 before we say 10 million into 52. So this will add another 0. 10 million into 52. I mean 10 million into 5, 0, 10 million into 52, 0, 0. So this will increase our zeros. Instead of having us having 7, but we are now having 8. So we can just count and say 1. Sorry, we're not counting 0. 0, you don't count it. You go on, say 1, 2, 3, 4, 5, 6. Then you just write your 52. You're done. So that is the correct answer that you have. There is nothing more and there is nothing less whenever we come to this part. This is how you can understand ordinary to standard and standard to ordinary form. So this is the part that is a very, very crucial. Whenever you understand this part, I think you'll be home and dry, and you will be very safe and sound. Okay, so now we are proceeding to another segment. I hope everybody's understanding, and I hope I'm not that too faster. All right, I'm going to another segment there that you need to take note of, and that is very crucial and important. Maybe they are giving you something like a certain number, like you are given a certain question or a certain problem, which is like 3,1 times 10 to the power of 3 plus 6,4 times 10 to the power of 3. All right, I need you to understand. If you understand this part, you will not go wrong. If you understand this part, you are already okay. All right, I need you to understand the exponents. The exponents are the same and the bases are the same. Exponents are the same, the bases are the same. So these exponents are guiding us that there is no use for you to change these things to what? To ordinary form, because already the exponents are the same. This is the tricky part whenever we come to this standard general arithmetic part 1. The exponents guides you not to stretch your head and try to say I'm converting this to ordinary form. Let me show you that it is one and the same thing. Alright, let's change this to ordinary form initially, as we have attended to this before. Are we there? Initially we've recently attended to something like this before. Alright, so you just know that if I've got something like this, remember now we are not having a negative power. So don't go back to that thing that we're doing, saying we have got a negative power. But on this case, you know that I've got something like what made us to be changing like this, that we have got 4 times 10 to the power 4 to ordinary form and say 4 over 1,000. It is because of this negative. This 10 has to go down because of this negative. But when it's now a positive, you can't make this 10 to go down on this part. But what you have to know is that this exponent is telling you about how many numbers must be after the comma. Are we there? So we can just say 1, 2, 3. Are we there? So it's telling you that after the comma you have to have 3 numbers, to sense that when you're changing it to be 1, 2, 3. So what you have to understand, you can dissolve this comma and make it not to be visible, but the exponent tells you that after this comma, no matter there's a number, there's whatsoever, it's telling you that you have this form of number. So we've got 3,100 plus, what about there, 6,400. Are we there? If you add these, you get your 5, you get your 9. Are we there? So we've got 6 plus 3, 9, 1 plus 4, 5. Clear? Right. So now this is in ordinary form. Okay, so I think it is clear. This is in ordinary form. Therefore, we need to change it to standardized form and standardized form. Okay, so to standard form, to change this problem now to standard form, meaning we do the same thing, we maintain what we did there, a times 10 to the power of n. This formula, don't dissolve it anywhere that you go, just apply this formula. So we move our comma 1, 2, 3, we move our comma 3 times to the left, so it will be 9,5 times 10 to the power of 3. Right, why are we having 10 to the power of 3? Whenever you're moving your comma to the left on these standard form and ordinary form stuff, general arithmetic, whenever you move your comma to the left, it simply indicates that you've got a positive exponent. But whenever you are moving to the right, you've got a negative exponent. In general, a person can contradict that and say on the number line, the negative part, or my negative hand indicates the left hand side, and my positive hand represents the right hand side. No, don't take it on that concept. The standard form and the ordinary form have contradicted that part. Just take it as it is. So this is the number that we get, but it was not necessary for me to go all this way. I've wasted my time in an exam. Instead of me knowing that my exponents are the same, I just add 3,1 plus 6,4. Are we there? You get 5, you get 9. I've get my 9,5. You see, then I take my one exponent, since they're the same, one exponent and one base. So I'll be having 9,5 times 10 to the power of 3. So there was no use for me to go all this way round about dealing, unless I've got a different scenario here. Whenever I understand that whenever I've got a different scenario, that's why you have to convert. Let's take a different scenario so that somebody can take note of and understand what we are trying to illustrate there. Guys, I think we are following. If you are not following and you are just asleep, try to wake up and follow the tutorial. It will help you. Yeah, it will help you, especially when you're writing. Okay, I'll take something like 1,7. This is from new general. This is the questions that I've took. If you have a new general, you can just go on page 11 and go with me on page 11. You get your 1,7 on number 17, exercise 1C. 1,7 times 10 to the power of 4 plus 6,5 times 10 to the exponent of 3. Right, this is what we have for this case. Here we are forced to go to ordinary form. You don't add the 2, you get a wrong answer because of these bases and their exponents. They are different. So you go on to have, I said 4 numbers, right? So it's 1 7. So already just put your comma so that you cannot what forget. Then after that dissolve your comma. 1,7 1 2 3 4. So 1 2 3 4. Are we there? So you've got 17,000 plus here 3 numbers after the comma. You now know that I've got my 1 2 3. Are we there? I add the 2. What do I get here? 0 0 0 0 5 0 7 plus 6. That's your 13 there. 1 plus 1, that's your 2. So I now have got a 23,500. Clear? Alright, so I have to redo it to be in ordinary. I mean to be in standard form, because this is ordinary. A times 10 to the power n. I will not forget this thing. I love this thing, this formula a lot. And I hope you have to love it again. Alright, let's continue and proceed. I have to maintain a number which is between 1 and 10 here. So here we have got a very big number. So I'll move my comma and I'll not stop here because it is 23 now. So I'll come up to here. So 1 2 3 4. Clear? 1 2 3 4. So I'm having my 2,35 times 10 to the power of 4. Clear? Because I've moved 1 2 3 4. So that is my answer. So what if I had taken this 3? What if I didn't know that I have to take this 4? You get the sense? So just try to change this to ordinary form. It will help you to understand whatever we'll be speaking about. Same thing. Let's just take a last example that deals with the negative thing, so that somebody can take note of something here, because you're already behind time. My video is now very, very, very long. 5,9 times 10 to the power negative 4 minus 4,1 times 10 to the power of exponent minus 5. Alright, so we have got this problem now. Let's attend to this problem. Hope everybody is still listening. Initially, we know that 5,9 over 10 to the power, we have got how many numbers? I hope people are still together with me. The exponent is negative 4. So over a 10,000. Are we there? Before what we did before, I think it is clear. Over 10,000, right? So the next thing that I'll be knowing that I'm speaking about, I'll not have when I'm changing. Remember I said you change 5,9 to over 10 to the power of 4. But remember I said you are not having what? 4 numbers after the comma, because this is a 2 number, 5,9. So you are now forced to have 5 numbers after the comma. So it will be what? 0, 1, 2, 3. Are we there? 5 numbers, 4, 5. So it is 0, 0,00059. That is what we have. Then for here, we are no longer going, we are behind time, guys. Let's just know what we are speaking about. For 4,1, we know that we are speaking about 4,1 over 10 to the power, over 10, how many numbers? 100,000. Are we there? Yes, over 100,000. Then it is the similarity as 4,1. Hope I'm clear there. Over 10 to the power of 5. Then initially we no longer have got 5 numbers, but instead we have got 6 numbers because of this thing. So 0, 0, 0, that's 1 2 3 4 5. Are we there? Sorry, 1 2 3 4. I'm no longer write this 5, so I'll just write 4 1. Are we there? If you take note of this, you can see that it's 1, 2, 3, 4, 5. Are we there? Then you go on to add. You go on to add these two. You attain something like 0,00059 plus. Sorry, it's a. Okay, progressing as we are subtracting there. I believe we are subtracting something there. Alright, so minus 0 comma, how many numbers? 0 0 0 0 4 1. Okay, so let's subtract what we have there. 5 here, 10 minus 1 9, 4 5, then 0 0 0 0 0. So the end thing that we have something like 1 2 3 4. So we have got something like 5,49 times 10 to the power negative 4. That is our end answer that we have on this one. I think it is clear for everybody. Are we there? So please, you have to know that 0,2 is bigger than 0,02. So you can't say 0,02 over minus 0,2. 0,2 is bigger. Be careful of those things. Are we there? Alright, so this is what we have, guys, for our lesson, and there is nothing more, there is nothing less on this one. Then we can have certain concepts like they introduce you on the multiplication, division. I mean, on the multiplication signs, like 3 times 10 to the power 8 times 2 times 10 to the power of 3. You have just to take note of that. I have got now I'm multiplying. When you're multiplying, just take these numbers as they are. Just multiply 3 by 2, which is giving you 6 times. Then our bases and exponents. Remember, when we were speaking about indices, they tell us something that is very, very nice, that I know. It says when you have got x to the power a times x to the power b, it is the same as x to the power a plus b. We shall go to indices whenever we are going to the next topic. Are we there? So it will be 6 times 10 to the power, we take 1, 10, 8 plus 3, so 6 times 10 to the power, you know that you are on 11. Out there, 6 times 10 to the power of 11. Whenever you're multiplying, just multiply everything. Then whenever you are dividing, let's take an example whereby you are dividing 3,6 times 10 to the power of 2 divided by 9 times 10 to the power of negative 5. Are we there? All right, fine. So we are dividing on this case. Straightly you divide, then you divide literally, just divide these things, these initials. 3,6 over 9. You know that I get my 9230,9236,4. So I've got 0,4 now. I'm now taking my basis. Whenever you are dividing, when it comes to indices, x to the power a divided by x to the power b is equal to x to the power a minus b. You just subtract. There we added because we're multiplying, here we're dividing, we subtract. So we take one base because they are the same. 10 to the power 2 minus 5, because we've got 2 minus 5 there. Are you getting what I'm trying to say? So 0,4 times 10 to the power 2 minus and minus the plus, so 2 plus 5, that's a 7. So that is our final answer that we are having on that part. So multiplication and division, that's it on standard form and ordinary form. So anything on division, anything is not hard. Here and here it's not hard. Thank you so much for being part and parcel of this class and this lesson. I hope we shall meet tomorrow on the next segment where we'll be dealing about number bases. Thank you so much. Have a nice day wherever you are. Thank you so much.